Let's consider one problem. In an island, there are two kinds of inhabitants: knights, who always tell the truth, and their opposites, knaves, who always lie. You encounter two people, A and B. Determine, if possible, what A and B are if they address you in the ways described. You need to determine what A and B are. A says B is knight, and B says the two of us are opposite types. Now let's try to solve this particular question using the ideas of propositional logic. Let's say P is A is knight and Q is B is knight. Okay? Therefore, not P would be A is knave and not Q would be B is knave. Let's try to solve this problem by considering some cases. Case number 1. A is knight. Now we assume that A is knight. That means P is true, right? If A is knight, that simply means that P is true. Now we know that knights always tell the truth, right? Therefore, A always tells the truth. As A says B is knight, therefore Q is also true, right? According to A, B is knight. Therefore Q is also true. That means B is knight. Now as Q is true, therefore whatever B says is also true. According to the statement, the two of us are opposite types. This simply means that P and not Q, or not P and Q. Isn't that so? When A is knight, B is knave. And when A is knave, B is knight. Right? Any one of them must be satisfied. Then only we can say that the two of us are opposite types. Right? Now, let's plug in the truth values of P and Q in this particular expression. As P is true and Q is also true, therefore not Q is false. Not P is false and Q is true. True and false is false, or false and true is also false. False or false is false. This is our final answer. Now this statement has to be true, right? Because as B is knight, whatever it says is true. The two of us are opposite types has to be true. But as we can see that the conclusion that comes out of this statement is that this particular statement is false and not true. Therefore, we can say that this condition is false. We can also logically think about this statement. As initially we assume that A is knight. Therefore, A always tells the truth. And if A always tells the truth, whatever it says is also true. That means B is knight. Now, if B is also knight, then this statement becomes false automatically, because if B is knight, whatever it says is true, and it says that the two of us are opposite types. Now, as A is knight, B is knight, the two of them are of same type. Then how can they be of opposite types? Therefore, this statement is false. And hence our assumption that A is knight and B is also knight is false. Okay? Now, let's consider the second case. B is knight. If B is knight, then Q is true, right? Now whatever it says is also true. That is, the two of us are opposite types is actually true. This simply means that P and not Q, or not P and Q, has to be true. Now as Q is true, this becomes false. Therefore, this whole proposition is always false. Now, the only way we would be able to make this proposition true is by making this proposition true. As Q is true, then not P has to be true in order to make this compound proposition true. As not P is true, P becomes false. Isn't that so? Right. As P is false, this simply means that A is a knave. right? As A is knave, therefore whatever it says is false. It says that B is knight. Now this is false. Therefore, according to A, B is knave, right? But what is our assumption? B is knight. But what is our conclusion? B is knave. This is the contradiction, and hence this case is also false. Therefore, our assumption that B is knight and A is knave is false, right? Now let's consider the third case. A is knave. Now, if A is knave, this simply means that P is false, right? If P is false, whatever A says is false, right? That is, B is knight is false. This simply means that B is knave, right? Now if B is knave, this simply means that Q is also false. Now whatever B says is false. That is, the two of us are opposite types needs to be false. Therefore, P and not Q, or not P and Q, this compound proposition has to be false. In order to conclude that A is knave and B is knave, this compound proposition has to be false, right? As P is false and Q is also false, let's plug in the values. P is false and not Q means true. Not P means true and Q is false. False and true is false, or true and false is false. Therefore, this compound proposition is false, right? This simply means that whatever the B says is false. And that is what our assumption is. B is knave. Therefore, we can conclude that A is knave and B is also a knave, right? Let's consider one more case, that is B is knave. Whatever B says is false. Now if B is knave, then Q is false. As Q is false, then not Q will be true. Then P has to be false in order to make this compound proposition false. As Q is false, this one is always false, right? Therefore, we can say that P is false. Now, if P is false means that A is knave. And if A is knave, this simply means that whatever A says is false. That means B's knight is false. And it simply means that B is knave. And this is our assumption, right? B is knave. So we can finally conclude that A is knave and B is also a knave. Let's consider one more part of this particular problem. A says at least one of us is knave and B says nothing. Now the first condition would be A is knight. Right. Now how can we write a logical expression corresponding to this sentence? P and not Q, which means Q is knave, or P is knave, or both of them are knave. As A is knight, which means that P is true. Let's plug in the values. True, and we don't know anything about the Q. Q means B is knight. Now B says nothing, right? In order to make this compound proposition true, we can take not Q true, simply. Then this whole compound proposition will become true, right? If not Q is true, that means Q is false, which simply means that B is a knave. As B says nothing, therefore we can say that B is a knave and A is a knight. Now let me ask you one question. Is there any possibility that A can be a knave? As A says at least one of us is a knave, right? If A is a knave, then whatever it says is false, right? The opposite of at least one of us is a knave is that no one is knave. But we know that A is knave. Then how we can say that no one is knave? And hence, A cannot be a knave. Therefore, A is definitely a knight. And we already proved that when A is knight, then B has to be a knave, right? You can check the other conditions on your own, and the final conclusion that you get out of this would be that A is knight and B is knave. Now it's time for the homework problems. You need to consider the same question, and these are the rest of the parts of that question. A says the two of us are both knights and B says A is a knave. A says I am a knave or B is a knight and B says nothing. Both A and B say I am a knight. You can always post your answers in the comment section below.